Hey guys, good morning. So for those of you who have just joined or have joined a little bit early, let's just wait a couple more minutes and then we can begin from around 12:05. Hi guys. Uh, so I hope I'm audible clearly enough. Can someone confirm quick?
Yes, sir.
Yes. Yeah. So let's get the basics clear, right? I'm just a fourth year senior of yours, so you don't really need to call me sir or anything, right? And if you want, you can also call me by my name. So I'm Dipankan, but we'll come to that later. But thanks all of you for joining in early on a Sunday morning. I know it's a little bit difficult for people to try and acclimatize on a webinar on Sunday at around 12. But thanks to you guys have a lot of curiosity to learn about new stuff, which is absolutely fantastic, right? And I guess right, most of you are from first or second year. Is there anyone who is like from third or fourth year here? Can you raise your hands? So I see almost none. So I take that as most of you are from first and second year. That's great actually. I mean, so we before I mean probably when you joined, right, you already had started with online classes. But for e-labs, so the society which is organizing today's meet, we have a long history. We started back in 2014 with our super seniors founding this organization as some kind of a peer-to-peer learning society, and we have had also offline sessions in our early days, right? So it would have been even better if we could have interacted offline, but I mean for the time being, this is what we do, and we organize sessions and try to build an interactive community of youngsters just like you and me, who are interested, who are passionate about the new upcoming technology and how we can make more advances with it going forward. So that is about elabs. But about today's session, what we have in store is a lot, really. So the theme you already know, which you have signed up for. It's called big data engineering, right? It sounds really it's like a ensemble of concepts. Really, it's a big data is just one word to kind of kind of coalesce all of that together. But I'll kind of take you through beyond the hype, right? So there's a lot of hype attached to all these words nowadays. But we'll see and try to demystify what big data engineering really is, and really understand the fundamentals, right? And what drives it, and how you, can make a career out of it, right? Just like some of us are. So just to give an intro of me also. So currently, as I said, I am in my fourth year, and I'll be graduating very soon in June. And I'm from the electronics branch, and currently working as a data engineer intern at Maersk. So for those of you who are not aware of what Maersk does, it's a world's largest shipping company, and there's a ton load of data that organizations of this scale have, and as part of a daily job, we kind of orchestrate that data, we bring that data, we kind of organize it, and make it in a very, to put it in a very simple way, make it usable for the organization to build some meaning out of that. So that is what data engineers do, right? So let's begin. All right, so do any of you have like a kind of good understanding of what cloud is before we even begin with big data handling? So you can be very kind of free and frank. So I mean, even I at a point, right, probably when I was in my first year, I did not know much about cloud. So if you guys, any one of you want to know or are not very sure of how cloud works, I just maybe for 10-15 minutes I can give you a brief walkthrough so that it aids in your understanding of how we handle the complexities of big data. So can you
Sir,
sir? Yeah, show me.
if you take in layman language terms, like cloud is something where you can like the datas and all that can be accessed from anywhere. Like if you're staying in one place and you have your data, I don't need a flash drive from my friend to ask for data. It's in the cloud, it's in the internet, so that everyone can access. It's like universal thing if you have the
True.
password. Yes.
True, true. So, I mean, thanks, Shomik, for that. I think that is definitely one aspect of what cloud does, and it's probably the most popular. Right, all of you use Google Drive, probably OneDrive, Google Photos. All of these are examples of cloud services, and more specifically, these are something like called SaaS. But we'll get to that also later, right? But cloud is it's a very big concept that cloud represents. It's not just about file sharing and file uploads. That forms a very very small component of what the cloud concept is. But the idea is that there are two for a, if you think about the business, right, at the end of the day, what matters most is the business, right? From business point of view, if you are running a business today and you need the computing power, right, you have two options. Either you buy all of that resource, right? You buy server racks, you buy hardware, you buy a lot of GPUs, you buy all of that, right, and you stack it together and try and run the business using the compute power that you have from there. That's one way, right? It involves a lot of upfront expenditure, capital expenditure. And the other way is based on your requirements, you hire or you kind of provision that resource from the cloud. So that is really what the cloud can do for you. It's kind of based on a pay-as-you-go model, right? It offers a plethora of services, and this is something that's today being used by almost all of Fortune 500 companies and even more, right? Even startups, right? Not just big ones. Even startups are leveraging the power of cloud because it reduces costs. It kind of gives you a immense flexibility to scale out. When I say scale out, right? If you say, for example, at this minute, right, you were requiring only maybe 5-10% of CPU utilization, and suddenly your product goes crazy in the market and everyone's trying to log in and keep an order for it. How do you handle all of that, right? Load balancing and all of that. So this is what the cloud does. There are basically speaking, fundamentally speaking, there are three models of how the cloud operates. The first one is the public cloud that you all know. So you must have heard about Amazon AWS. I'm pretty sure it's by far the most popular public cloud service out there. You might also have heard of Google Cloud Platform. Right, a lot of people on LinkedIn are posting about getting swags from GCP, completing challenges from Quick Labs and getting those. So GCP is also one more public cloud platform. And last but not least, we also have Microsoft's own Azure platform, which is something that we are going to discuss further today, because I personally use Azure Tech Stack. And frankly speaking, it's very easy to acclimatize once you get accustomed to one public cloud service. It's more or less the same, just the names and a little bit of service may be different here and there. But the three models are: one is public cloud, which I just told you about. You have something called a private cloud, and you have something called a hybrid cloud, right? Now, what does public cloud mean? If you think about it, right? Uh, does anyone, if you know, right, what's the difference between public or a private? In very simple terms, okay. We don't want bookish definitions here, but can
Private
someone, yeah, go
private
ahead, Rohan.
cloud is they are used basically by companies and industries where the employees can access data, and public cloud is something like it is for everyone, like government websites. They have data for everyone. Anyone can access them.
Okay, so little bit. I mean, you went on with the right track. So kudos to that, Rohan. So you have the fundamentals, but a little more precision probably would have helped there. So when we say public cloud, right, companies like Azure, right, or services like Azure, services like AWS, GCP, they offer their computing services to a lot of organizations, right? So they are offering their service to probably some of you might run a startup tomorrow and you might hire their services. So you are taking advantage of AWS or these services, right? They're at the same point of time, they're also offering services to big companies, right? So, say, for example, Cisco, right? They're offering their services to so many big companies, and each of them is kind of bucketized. So they're also offering services to big corporations, they're offering services to you, right? And that is what the public cloud is. So it's like the infrastructure is same, but the resources are being shared and allocated to different people, different organizations on a need basis, right? Kind of as and when the demand comes for it, right? So the infrastructure is same, the resources are shared. That is called the public cloud, right? And it is mostly right done in a. There are a lot of ways to secure your premise, like the cloud, public cloud premises, right? You have a lot of authentication measures, you have a lot of authorization measures to kind of prevent breaches. But again, right, there are certain regulations that require that data must not be right. Some companies have very very critical sensitive data that they believe if they upload on cloud, it may violate their legal policies that they have. And so what they do is they kind of have their, which I discussed about at the outset, right? They bring their own infrastructure. They purchase all of that upfront, right? And they have their own servers in their organization, and they kind of set up an intranet, right? So in that intranet, whoever logs in using that company device can access that intranet and get that data, but it is not available on the public cloud. So for example, if some external client wants to have a share of that data, right, for some reason whatsoever, he has to use some kind of gateway to access that intranet, right? It is a little bit more tedious. It's a painful process really, in terms of the data sharing. But from security perspective, it is probably the best, right? But it has right a lot of constraints. You have to invest in it upfront. You cannot. There's not much of flexibility, and if your demand tomorrow rises suddenly, you cannot handle that. So going forward, what happened was that people thought, right, what if we could merge the on-premises solution, which is your private cloud, right, with the flexibility and the popularity that public cloud was gaining. And to put it that way, right, they came up with a term called, I mean, it's not surprising that they came up with it. They came up with a term called hybrid cloud, right? So in this kind of model, cloud model, what happens is that you have a part of your resources that run on, say, your public cloud. So, for example, right, whenever you are trying to, access some database or something, that may come from your on-premises through some kind of gateway, because that data is sensitive. And for example, say when you're trying to access lots of data strewn across, right, which is flowing in, that you can leverage the cloud data storage. For example, Amazon's S3, Azure's Blob Storage, GCP's bucket storage, anything, right? So if you have a mix and merge of both public and private, that's called your kind of hybrid cloud model. So this is about cloud to get started with, and just to maybe 2-3 moments more I can spend on the further three subdivisions of cloud, and then we'll take a small break to understand if you have any kind of conceptual doubt, and then we will move forward with actually the highlight of today's session. So again, within the three cloud models of public, private, and the hybrid models, we have kind of something called infrastructure as a service, right? We have something called platform as a service, and we have something called software as a service, right? So probably the most used, right, and you guys are most familiarized with is something called SaaS, software as a service. So what's SaaS really? Let's get started from the top to the bottom, right? So when you open up Gmail, right, most of you are using your Kit Mails, which is a Google Workspace setup. So you really don't know, right, what the underlying provisions are. So definitely you know that for storing your attachments, for storing your mails, to send your mail, definitely some underlying architecture is there, right? It cannot happen out of magic, right? But you don't know. And most important fact is that you don't need to know how it is working, right? All you need to do is you go to your mail, you check your inbox. If you want to send mail, right, click on a compose mail and you hit a send. That's it. That's the magic of SaaS. And it's built for end user convenience, right? So SaaS basically means any kind of software that is built specifically for the end user, and it's mostly targeted towards laymen who do not really need to know how the underlying thing works, right? So that's SaaS. So when you for example, right, when you also go to maybe some software like Microsoft Word, right, online, these are all SaaS, right? SaaS software. So this is the thing which you're most familiarized with. Now, what is IaaS, right, which is infrastructure as a service? Let's kind of this is where things get fun, right? I told you about something called provisioning of resources, right? And you don't need to buy the resources upfront, right, when you kind of provision it through cloud. So for example, just think of it, right at this point in time you need to have access through at least 5 machines. But do you want to go out to some computer store in your locality and get 5 devices onwards? And probably you require that maybe for 2-3 hours, right? Doesn't make sense at all. So what you do is you go to some of these cloud platforms, you fire up these virtual machines, right, and they're ready for you within what, maybe less than 1 or 2 minutes, right? So that's what IaaS is. It gives you entire control, right, from the operating system, from your kind of, you can also decide on the hardware configurations that you use, and all kind of software patches, maintenance, everything. That's your responsibility. But at the end of the day, you get the device that you want, right? And it's a very quick process of deployment as well. So the most amount of flexibility is available on IaaS kind of service. When you talk about platform as a service, which is kind of abbreviated as PaaS or PaaS, it's something like the underlying architecture again is managed by the cloud provider, but you have an ability to configure the higher software that you are actually targeting to use. So let's talk about maybe something like a SQL database, right? So if you want to run a SQL database, right, the first thing that you need is you need to hire a server for it, right? Obviously. And there are two ways. You can either do it through IaaS, you can provision a virtual machine, you can set up all the configuration, make all the network settings updated, then get your SQL server installed, build a SQL and expose that on the internet, right? It involves a lot of work, right? But on the other hand, what you can do is, if you go to some service like, say, for example, Azure SQL, right? Then you can just provision a SQL database. Azure takes care of the operating system and all the underlying configuration, and it gives you the credentials to access your database. So all that tension, right, of handling that underlying architecture is now removed from your head, and you have access to the service that you require. So that is about PaaS. So now that we discussed about IaaS, SaaS, PaaS, and also the three models of public cloud, I'll just quickly check chat if there's any question, and if you have anything, quickly, then we can also probably discuss right in the meanwhile. So I can see one question: what are the skills and knowledge required to know before stepping to learning cloud? Okay, so I think to be very honest, you really don't require much of a prerequisite in terms of learning the cloud. It's just that you need to be a little more curious. It can get daunting at times. From my experience, I can share with that with you. It can get a daunting at times to, first when you open up cloud, right, it seems like a plethora of services. It's a lot of services that they offer, but take it slow. Think about your use case. Always think about a use case and a problem that you want to solve, and then hunt about it. How cloud can benefit your idea or business or startup, whatever it is, right? And then go in that direction. Don't try to learn everything at once. Go slow. You should definitely, make it easy for you. So, apart from that, any other questions, guys? Before we begin with our data fundamentals, and feel free to ask any questions. I mean, you can also reach out to me later. I'll also share my LinkedIn with you. And but yeah, if any questions, you can ask me. Otherwise, I'll proceed with the data segment. Okay. So I guess for now we are clear. Right. Thanks, guys. So let me present my screen. So just let me know once you can see my screen, right?
Yes, sir, visible.
Okay, perfect. So just before we begin, right, so let me give you a disclaimer. So I am having some issues with my laptop of late. So this is still my kid laptop, right? I got it in 2018 from the institute, but of late it's been having some high RAM issues and something. So if I get dropped out for some reason, kindly be patient. I'll try and log in within some quick minutes if I get logged out. That is for some reason. But yeah, let's begin, right? So let's talk about the data fundamentals first, right? So about big data, right? There are three V's that is very very kind of the base of big data. How do you define big data, right? So the three V's are your volume, your variety, and your velocity, right? So how do you kind of handle these kind of challenges when you process big data, and what do these three V's mean, right? So when you talk about volume, right, the amount of data that's being generated daily is immense, right? Let me tell you that upfront. I have seen databases which are greater than probably 900, probably greater than 1,000 terabytes in data. This is about volume, right? You can imagine it's not possible for a single machine to deal with that kind of storage, or even probably with that kind of compute power necessary to deal with that processing that storage, right? The second is your volume. Sorry, we already discussed volume. Variety, right? So when you talk about variety, right, in earlier days you had very simple storage formats, right, for data. So you could have a table, you could have maybe a CSV, Excel, text file, something like this. But nowadays, right, as days went on, the variety of data really changed. Now you have kind of document type data storage, right? For example, JSON, or for those of you working with a front end, you also have MongoDB's own version of JSON. So all these kind of document databases that you have, which are called semi-structured data. And last but not least, right, you also have a lot of media, right, being strewn around all of the platforms, right? Videos, audios, and so many more, right? Probably. So all of this data, right? There are several categories. So this is a variety. And the last thing is about the velocity. So when we talk about velocity, what comes to your mind first, right? You think about the speed, right? You think about how quickly something is moving or happening, or that's what velocity is ideally. And when we talk about velocity in context of big data, what we are truly meaning to say is whether data is flowing real time, right? So at every instant of time, right? Suppose you are handling big data for a banking firm, right? So at every second, probably lakhs of transactions that are happening, right? So that is real time data that's coming in. right? And if you think of something like the industry that I am currently working for, right, a shipping industry. So apart from IoT devices which stream data real time, there is mostly a requirement of something called a batch load. Uh, so what the batch load is basically, you collect data and you process them at intervals of time. So it's not real time processing, but you process them at intervals of time, and that is called a batch load. And the form on which comes in and occurs at a real time is called a streaming kind of a data workload. So this is about the variety, velocity, and volume of the big data. And if three of these, go about exceeding the limits of probably a reasonable amount of storage or compute power that a machine or a group of machines can probably at max handle, then it's definitely something that you call big data. But yeah, so basically, right, so for data types, right, as I talked about, so you have structured, you have semi-structured, you have unstructured. So I already covered this for you during, while describing the three V's. But if you look at it, right, for structured data, it's easy to handle, right? It's very easy to handle. So if you have a table, right, you can directly query and get the and you know about it, right? Already you know about it, how it is supposed to be, and what are the parameters, what are the data types, you know all about it. If you look about semi-structured data, right? For example, this kind of set, right? You have to know the parameters, right? But within those parameters may also be kind of multiple layers embedded onto them, right? So that is a semi-structured data. And the last thing is your unstructured data. So you really, it's very hard to kind of process them at. You have to kind of take specialized processing steps to query those kind of data and try and make meaning out of them, which is audio files, your video, your complex embedded documents, and so many more, which cannot be categorized in the first two kind of variants, right? And my personal guess is that with coming days, the more we will have unstructured and semi-structured data, and structured data will be, kind of very less in volume compared to the semi-structured and the unstructured part of it. So the next important, give me a second. Yeah. So the next important part of this revolves around how you kind of use that entire data that you're having, right? I talked about already batch streaming. That is about the velocity of your data load, and OLAP and OLTP, right? As you can see already, the full forms, right? These are two kind of workload analysis or workload handling kind of types that you can say. So in online transaction processing, I'll give you a very quick example of what OLTP is for, and then I'll tell you about what OLAP is used for. So you're purchasing right from Amazon, right, or Flipkart or whatever, right, some kind of online e-commerce store, right, and you make that, you go to that product, you add it, you click on the add cart or buy now, whatever it is, and immediately, right, in a backend database, something is stored that you have added it to your cart, or you have clicked on that buy now, right? It's stored there in some of the database. So that is one entry, that is one transaction that happens against your ID that you have booked, or you have selected this kind of quantity against this product of this many stock left, and you are probably going to check out in this much of a time. Right? I'm just telling, I don't know the underlying parameter, but this can be one example. And then when you finally make that purchase, right, maybe after 3-4 minutes, right, you enter all that address, you give the your banking credentials, and you go forward and make that process, right, payment process. Then probably in your order table, right, that reference that was built earlier for you is now referenced, and you have another transaction happening for your ID that, hey, for this particular ID, I have now an order, and I can check that my customer, right, I have already made an entry for them in one of my earlier tables. So this is how OLTP works. It's kind of it's a mode of write optimized, if you can look at it that way. So if you're writing good volume of data in a structured format very quickly, I think nothing beats efficiency of OLTP in that direction, right? But as I said, it's write optimized. It's probably, you can do read, and read operations are indeed supported. But if you're looking to analyze big chunks of data, if you're looking to kind of make sense of that data, it's probably not the best way to go about reading that. But then how do we handle that, right? Then that, because that is also an important criteria that we require in terms of how do we process that data, right? So it's something that's called online analytical processing, which is called your OLAP, right? And what OLAP does is basically it takes all of that data, and instead of being write optimized, it is more oriented towards read operations than write operations. So, for example, again coming to that, say the Amazon example that I was quoting a few minutes back. So every day, right, there's a date time column that's definitely there in one of the tables, which is all like logging, right, at every second how many orders are being generated, right, in some of the backend table. And suppose higher management, right, they want to know that for this, so they find out, right, suddenly the sales have declined or suddenly sales have jumped, right? But they will, I mean, coming from real business experience, they are most concerned when the business is not going well. So suppose there's a slump in the sale, right? So they will then ask, right, that can you show me the data, right? Why it is suddenly it's fallen, right? And then how do you understand, right? You need a model to process. So what you do is then you kind of read that data from OLTP and bring it into OLAP, right? A kind of a model. You first perform operations on it. You perform aggregations on it. Say, for example, you if you aggregate by the date time, right, or a date field, right, on this particular date, right, you have say 1,000 entries of 1,000 orders being placed, right, out of which say 500 are from category A, 300 are from category B, and 200 are from category C. And then you can kind of aggregate that by the date time, then your category, and then your count, right? And you can do all of that very quickly in OLAP because that is specialized for that kind of operation, and store that in something called a queue, right? It's called a data queue, and you can access that very efficiently from most of the front end services that you have for data analysis today, whether it be Tableau, whether it be Power BI, whether it be so many SSAs, so many of these reporting tools that you have, right? And most of these can connect to our queue, and it's very efficient. And I'll give you a very quick example of how efficient that is, right? So we have in one of our databases almost near about 17 million rows of data. So just to give you a context, right, your Excel probably max out at 1 million rows, and trying to open a 1 million row record Excel file is, I have tried it, and I definitely not recommend you guys doing it on your local machine. But if you think about 17 million rows, right, and the user must not be feeling that lag, right, when they try to access that report. So 17 million, anything, any filter can be set by the user, and the data must come right within a fraction of a second. There you go. OLAP is a solution for it, and it works absolutely like a charm. I have seen that, and I can definitely tell you that it's very much optimized for these kind of workloads. So that's about OLTP and OLAP. The my greater idea, guys. So I'll again kind of tell you this upfront, that there are a few concepts which probably you will find a little bit challenging to understand probably when you listen to it the first time, right? But I'll try to make it very, very simple for you guys from my personal experience and what I have seen, right? And combining it with the theoretical knowledge that I have had earlier from my college days. I know the pain points that students go through, and I am trying my best to kind of simplify this. But again, if you have any kind of question, definitely you can, tell me right away, or probably better to connect with me later, and in the interest of time, we can also go through that way. So again, I will not take much of a time, but this is just kind of a visualization on what I told you some time back, which is about the batch and streaming data. So streaming data, you can see, right? It's like the dashed line below, right? It indicates that at every point in time, right, it's coming in and sitting in some storage, right, that we have. And batch is like at one point of time we are loading it. Again, at some point of time we are loading it. So it's like a kind of you stop and then you process and then you put it back in your and dump it in your data storage, whatever that is. So this is actually now we are getting into the fundamentals of the kind of handling that volume of big data, right? So there are two models for it. Let me check. Yes, so we will discuss that right away. But how you basically process your data is, for example, you have some kind of front end app, right? And when I told you about that Amazon example, when you are logging your adding to cart or you are proceeding with a checkout, right? All of that data real time, right? Or maybe even if it's not a very business sensitive data, right, it can also be, or business critical data, right, it can also be loaded at a batch load. So that's really on the organization to decide. And then what you do is, right, before you can actually make sense of the data, there are a lot of variables, there are a lot of fields, right, probably which do not have a good data quality. And let me tell you that data quality is, undoubtedly, it's one of the biggest challenges that we as data engineers face. Right? How do we make our data, raw data tables, right, much better in quality, right? In terms of what is the value of data that we get out of it, right? And is it a reliable data that we are getting out of it, right? So there are a lot of things, right? There may be a null value spread across. There may be corrupted entries in the records. How do you identify that? How do you, make sense of that, right? And then maybe something like in a lot of big description, big text, and you have to only find specific numbers or specific keywords out of that, and extract that in a separate column, right? So there are so many different kind of processing operations that goes on, but the fundamental is that you get your raw data, you process it, and you then clean and kind of dump it in your storage. That's the high level overview, if I can talk about it that way. So there are two models how you can do that, which I just told you about, how you bring your kind of the raw data from your front end to your back end, right? So there is two models. One is called the ETL, and the other is called the ELT. So what does ETL means? ETL is, as you can see, right, it's an extract, it's a transform, and then finally it does a load operation. These are three big terms, I know, right? But then let's try to try to understand the fundamentals. What is this concept really? So you have, for example, when you are doing that kind of ordering, right? When you're clicking on the checkout, right? Definitely a log is generated in your raw data. If you have any kind of sensitive information that you probably don't require for reporting operations, right? You have an ability to kind of select which are the fields that you require, first of all. So you definitely don't require the credit card CVV and the credit card details. So if you're going for only for a reporting kind of a need, so you can discard all the fields that are not required or sensitive, right? It's upon, again, the business use case. You bring that, you extract that information from your raw data system, and you transform that in some kind of middle staging layer, if you can call it that way, right? So it's not in the target store that you go and transform. It's in the engine for transforming is a separate one than the storage engine, right? So you perform all the filtering operations, you perform all the cleaning operations, whatever you need to do, and once that data set is ready, then you bring it and dump it onto the load target store. So it can be as your database. It can be, and I'm just telling as your as an example. You can definitely kind of equate it with any of the cloud services that probably your business uses, or probably want to use. Right? It's the idea is same. And the other model that we have is called the ELT, which is called extract, load, and then transform. So why two models? First of all, whenever you see any kind of two models being created, or so I still remember, right? So in your class 8 or 9 at that time, you had read about something called a plum pudding model of electron, right? And then you had Bohr's electron model, right? So the first thing that you must ask is that why? What is the requirement when I already have a process and it's accepted? Why do I go for another process, right? So that's an important question. So if you think about it, right, ETL, the major drawback of this is that it takes a lot of time for this transformation to happen, and then it is coming onto the load storage, right? And for reporting operations that probably require a little bit of more or less of latency, then definitely it's not very good choice, right? And ETL operations can trust me, it can take up to 8, 9, 10 hours probably if the data is significantly high. So instead of that, now what we have is that ELT, right? So what you now do is directly from the source or the raw data, right? You bring it and dump it on your the data store that you want to store it in, and then once it's loaded there, you can then perform the transform operations, because the storage engine and on top of that whatever the compute engine that is deployed, it is much more efficient than a single independent transformation engine that runs between your source and your target data load, right? So this is a much more efficient way of doing it. But again, ELT has its own, kind of drawback, and we're not going to go into that much of technicality. But yeah, overall high level, you can think that ELT is a kind of a better choice when the data volume is, it's a bit too perplexing. But otherwise, there are pros and cons for both. If you are interested, you can definitely read up on that aspect as well. So this is the kind of flow about how you handle the big data, right? So when I talk about the flow, right, what happens? So first of all, as I said, so you have some bout of on-premises data, which is say very secure, very sensitive. So you don't want to bring that to your public cloud. That's fine. Let it be there. Then you have your public cloud data, which is your storage data across your different whatever the data be, right? Tables or whatever it be, right? And you store that in your public cloud for greater flexibility and scalability. Right, and finally you have software services. Say for example, Salesforce. Salesforce is it's a great, very powerful CRM tool, right? So whatever the customer communication is happening, definitely you can analyze that to Salesforce, and Salesforce also can send that data, right? So you want to bring that to a unified platform first of all, and for that to happen, again you need to ingest. And when I talk about ingest basically it sounds a little complicated, but ingest means that it's just basically trying to feed off that data from the different sources, right? So that's about data ingestion. And how data ingestion works is by basically through connectors that you have. So there are connectors to a lot of services, and you have a connector to, say for example, Google spreadsheets. You have a connector to, say for example, CSV file. You have a connector to probably database. So there's a lot of connectors existing, and probably so far I have seen more than 200 connectors available for accessing data across different platforms and types. But yeah, the data ingestion process happens through using the connector. Then once the data is ingested, you need a data storage, right? Where do you want to ingest that data? So you need a data storage, right? So already you have seen about the SQL database. Already you have seen about this kind of conventional like database storage. But there is a growing popularity of something called a data lake, right? And probably you can see this icon and recognize that it looks like kind of a water, right? It's kind of like a lake, right? And the idea of data lake is basically whether you need data or you don't require that data, but it's good to have the data if you ever require it in the long term, right? So there's this is actually it's a growing popular choice, and most organizations are today leveraging the data lake, right? It's called a lake house architecture. Again, right, I will not be going into very conceptual detail because it's a little complicated, but yeah, the fundamental idea is that you can store everything at once in an integrated platform, and that is the lake house or the data lake, whatever you call it. And then finally, as I said, right, you need to process the data. Raw data is seldom useful. You need to process that data, and there are three stages of that. So you have a raw data table, you have something of kind of a cleansed data table, and finally you also need to have the business table, right? So you need to have a business table. So it goes in three ways. So first you have this raw data, then you perform operations and make the cleansed table out of it, and then you perform joins with other tables, right, that you might require, other dimensions that you require in big table that will give you the business requirement or the business analytics, whatever it is like required. And then finally you can use some data visualization tool, right, to present that data for your end user or your stakeholder, whoever that be. So these are just basically some kind of data formats, right? These are very popular. CSV, JSON, I think most of you would know that. CSV, I think most of you definitely. JSON, for those of you who don't know, it's a very popular kind of quick data format. So it's kind of like semi-structured again. But whenever you say, for example, you query an API, right? If you go to any API, right, and you hit a GET request on that, the response will often come back to you in JSON format. So it's like kind of begins with curly braces, ends with curly braces, and it's like a kind of a dictionary. If you have know about JavaScript or if you know about Python, probably you can relate with Python. Most of you are doing Python, right? It's kind of like a dictionary, key value, entry pair, and there may be multiple layers for that. And it's if you know the structure of JSON, it's very easy to get and extract the data out of the JSON. And there are a lot of tools that have made it more easy by the day. But I'm probably you're not very sure of, or probably never ever heard of these kind of data formats as well. And yeah, so my voice, also speaking at a continuous length, right? Just dries up a bit. So sorry for that. Yeah, so probably you've never heard of these formats. In fact, before joining the industry, I also had never heard of Parquet format, ORC format, Avro format, right? And there's so many different types of formats, right? That's available. But basically, these are the formats that you require for handling the big data, right? CSV JSON is fine for small data, right? But if you're really talking about the volume that we are talking, right? 800 TB, 900 TB, petabyte scale data, right? It's definitely Parquet, Avro, all these formats are optimized for that, right? Again, these are having a lot of kind of details. And if you want, right, I can suggest you a book later on when we talk about it. And if time permits, I'll definitely give you those suggestions. But you can read about them. It's a very popular storage format for handling big data. So as we were talking about, basically, what's a data lake? What's a blob storage? I have simplified this a lot more and only kept the thing probably that you would require, right? So blob storage is basically like in Azure, it's called blob storage, but you have equivalent services in all of these cloud platforms, right? So basically, you don't need to get into the details of all these three. Just understand what blob storage does. Blob storage is basically it's like a kind of a repository of your files, right? But it's not neither is it a kind of file sharing service, neither is it kind of like a file network file protocol, right? That you can access through. So blob storage is basically when you have big chunks of file, right? Say for example, your 200 megabyte Excel file, or you may have some kind of a big video file, right? All of them you need to store for some reason, right? For your organization requirement, then you can store it in the blob storage, right? And it's very very cheap. It's I mean, exact rate you can go ahead and calculate on your Azure service or whatever the pricing calculators that you have, but it's really super cheap. If you compare the rates, it's really really cheap to store big amount of data in any kind of format, unstructured, structured, whatever it be, in your blob storage. And there are some of the tiers, and I actually have a scheme, like a diagram for that access tier. But yeah, this is the idea of blob storage. And remember that I was talking about your data lake, right? So it's probably a great visualization that I found on net, which is about just like a lake, right? And there's some kind of pipeline you can see here, right? And the tap, right, where the it's being pushed through in this kind of repository where it's called the data lake. You have a lot of data in this, whether it be structured, table format, whatever it is, right? And the best part about it is that you can, it is optimized for handling big data, and it's like you can at the individual folder level, right? You can give the kind of authorization permission. So for example, in an organization, I and you are there, right? Who are employees of the organization who need to access that kind of data. But say, for example, you are authorized to access the banking credential while I am probably not authorized or not having the permission. So if I try to query that data, it's on the same data lake, mind you. If I don't have that access, right, or not the access, it's like the authorization, better to call, to access that data, then I will not be able to query. But it's the data is sitting in the same location. But if you have the grant or the authorization for that, you can go forward and query that. So that's the beauty of data lake. It stores a lot of data, and it's very optimized to query in a real time or very quickly, right? And this is not so important. So let's go to this access tier kind of thing, right? So I was discussing when I told you about the blob, right? There are some kind of like tiers that you have for the storage, right? And the pricing of your storage depends on these access tiers and how you manage the life cycle of the data that you have or you bring into your blob data, right? So basically, you have three tiers. You have a hot tier of data, you have a cool tier of data, and you have an archive tier of data. Now, it's important to understand what of these three mean and what are the implications if you choose any one over the other, right? So, for example, when you talk about hot data, right, what does hot data probably bring to your mind? So now I want to ask you before I give you the answer, right? What do you think hot data means? Can anyone just whatever is coming into your mind, right? Just can someone of you tell me what hot data means?
The data which is frequently used.
Absolutely. I mean, thanks. What's your name?
It's Vaibhav.
Okay, Vaibhav. So you are absolutely on point, and this is what, in fact, it means. Well, you made it very simple, and I laud you for that. I think it's the best way to put it. Data which is frequently used is called the hot data, right? So, for example, right, if you require every day some report is being generated, right, and the report must be dumped into that blob storage and later, right, be fetched out of that, and the latency must be very minimum, right? That is hot data. So, as you can understand, right, hot data, the kind of like the cost to store, right, it's very high, it's the highest, but again it's cheap, but within that layer also, right, it's the highest if you compare among the hot, cool, and the archive tiers. And as I said, right, the access time is the lowest for the hot data. So you can see, right, that this is the lowest point of it, and the storage wise the cost is the highest for the hot data. Cool data is kind of, somewhere in between, right? I mean, the data may be required, or probably you can push it to archive in, say, maybe 15 days, something, and you just want to keep it, but you also are not sure if you want to access it in a frequent. So you can keep it in your cool tier. So it's kind of like a middle tier. And the archive tier is basically it's like some business, right? It will have some regulatory compliance rules and it has to follow. So, for example, if you are trading with, say, Grow, Upstocks, anything, right, any of these platforms, they have a legal liability to store that transaction data. And they are handling so many of this data, right, at every second. But they still have to, because if SEBI calls them up for some, complaints, they have to show that data that they have, right? But then how do they, or what do they do? How do they store it? Because if they're storing it in hot tier, there's a ton load of data that you're storing in hot tier, and it's going to cost them a fortune probably, right? But if they don't require that cost and they don't require that burden, but they still have to keep it if ever required. So these kind of case where the data, like, it's not going to be required, but still for compliance purposes, you have to keep it. It's kept in the archive tier. And as you can see, it's the lowest in terms of the cost. Like, it's very, very, very cheap. But the downside to it is that access time is mind-boggling, dude. So I tell you, from my experience, I have tried putting data in archive tier and trying to retrieve the data. I think so for hot tier you can directly and even cool tier it's very quick. So hot tier is within like a second you can get the data. Archive tier, it's like I mean it'll take you at least 10, 12, 15. I mean it depends. At least you take it that it'll be 10 hours before you get the first byte of data to your stream to your system. So that's it. That's a disadvantage. But again, right, because the storage cost is so low, right? Microsoft or whoever the cloud vendor, right? They have different mechanism to handle this kind of data. So that's about the hot, cool, and the archive tier. And it's very important concept, friends. You guys are currently in your first, second year, and let me tell you, today the hype is more about data science, if you have heard of it, right? And full stack, and all this. There are definitely no doubt there, great fields to go for. But if you think about it, right, for an organization, right, data science can only come if the data is there in the first place, right? And that's what data engineers do. They bring the data, they process the data, they keep that entire flow running so that data is available for the organization. And as you must have heard, right, data is a new oil. So if that data is not coming in, then there is no use of data scientists and data analysts who come after what the data engineers are laying the bricks for. So, and one more thing is that from my experience, that big data, it's very expensive if you try to do it on your own. So when you go for an interview for some kind of data engineering position later, if you talk about this concept, right, definitely 100% the interviewer will be happy, because these kind of concept is very rare among the people that I know with. I started a bit early on in terms of big data and the concept because I liked it. But today the trend is more of data science. But you really got to understand how data is fundamentally constructed and kept and managed, right, for the process to happen. So you can try and leverage. You can keep a note of all that I'm saying, and definitely I'm 100% sure, right, even when I pass out, well, 2-3 years down the line, you may be benefited from it, the kind of a takeaway that you're having today. So now the another segment of it is like the kind of relational database, right? So most of you probably in your third year, or I'm not sure when the course is for you, but you will have a RDBMS subject, right? So if you are from CS especially, and even if you're not, and if you're attending today's session and you have an interest in big data, please do go through RDBMS. I think it's very important for this field, right? So RDBMS is basically, or relational database is basically like it's a specialized kind of storage, right? It's always data is stored in tables, and this kind of database.table format that you have, and a table, right? It is always kind of a R cross C. It's kind of like a row and column. You will always have that format. Most important is that all rows will have same number of columns, right? So if you think about it, the fact is that the column values may be null, or column values may not be correct. That is another aspect. But if you think about JSON, right? Today in one field you may have kind of 3 columns. The next entry you may have 4 columns for the same record. That is not going to happen in relational data. So it's very strict as far as that is concerned. And finally, each column that you have, it will have a certain data type attached to it, whether it be a int, whether it be a long, double, string, right? Whatever it is. String is for database, it's called varchar. But yeah, that's what. Every column has its specific data type attached to it. And probably this is also one more important principle, which is the ACID principle, which is called. So just a second. So yeah, ACID principle, right? I mean, the name sounds a little funny, but when you come across it, I think it's one of the basal concepts that you have in database, which is the concept of atomicity, consistency, how you isolate the data and how you make the data durable, right, or the transaction durable. So atomicity is like, suppose for example, right, when you are going to a ATM, right, it's a most cited example if you have already read about it, but it's also the most easiest example to understand. If you're going to an ATM, right, and you kind of put in your card, right, and you want to withdraw some amount of money, and in between, right, uh, suppose when you put in your card, the network was there, but in between something happened, and that failed. Transaction failed in the middle. So basically, it will not be like, you got the money, but it's not deducted from your bank account. It is not possible, right? See, even if it fails, definitely you will not get money. Or if you get the money, definitely it will be, deducted in your bank account. So there is nothing in between, right? That's called atomicity. You guarantee that the transaction will happen. If it fails, it's not going to work. That's it, right? That's the first principle. When you talk about consistency, right, there are certain requirements when you handle the data, right? For example, if you are talking about a school database, right, for a class more specifically, right, you can say that every student must have a unique roll number, right? So if anyone tries to kind of make a double entry on that roll number, the database will not allow it, because it has to have some consistency, and you can enforce constraints on the database or the table that you build as to how the entry should be, or what are the rules that it's being checked, right? And all these rules will check dynamically whenever you load data, or whenever at periodic interval you also it will be checked. If any violation, that record is not going to be accepted. So that is about the consistency part. Isolation part is it's a little more abstract concept to kind of understand, but I'll try to make it clear and simple, which is, suppose any kind of real-time operation is handling. So every second, suppose 10,000 records are being written into a database, right? But it cannot happen that while you are writing that data, while the process of writing that data is going on, because you're writing that particular data, another data transaction that's also going on parallelly, right? It will fail, or it will, because of any linkage to this transaction that you are dealing with right now. So for every transaction, you can think it's like a separate kind of process that goes about in itself, right? It's like an independent event that happens, and then it's logged in there. So there's no dependency when a transaction happens. There's no dependency on any other transaction or any other processes that govern it. So that's the principle of isolation. And the last thing is your durability. So you have something called commit, right? A committed state for your database. So people who have explored Python and people who have explored SQLite database, right, probably you will already know that to write some kind of entry in your SQLite, that you have to commit that into your database, right? And that means that once you've committed that, the database is going to store that, no questions asked. Even if your system fails, once it's committed, it's committed. Even if you want to access it at some data point of time, you will be able to access that kind of data. So this is the kind of compaction. It's called an ACID principle, and it's a very popular interview question in terms of not just trying to understand about how much you know, but it's also about conceptually how better you can explain what ACID is. And it's very critical to all kind of data operations. I think it's the most important probably. So SQL actually, it's like it's a query language. It's a very simple language, much simpler than probably if you're getting started with programming today, right? You probably are doing C. Probably are, for people with ICC background, you probably would have known Java, C++, and Python, and so many languages. SQL is also one of these languages. But SQL does not build any kind of specialized front end or back end kind of software. It's like a built to query database. It's an extremely powerful query language. So SQL, basically the full form is structured query language, right? And it's pronounced SQL. And it's not SQL, but you can, I mean, if you want, you can call it either. But it's an extremely powerful tool, right? And there's a lot of possibility that you can use when you're dealing with SQL, right? And these are the fundamental kind of category of this query. So you have something called DML, DDL, and DCL. So suppose you have a table, right? And tomorrow you have, suppose for the student example that I was telling, right? For one of these tables, right, you may want to kind of have an update in the where the student lives, right? So you have to run an update statement, right? So you may be writing like update, and then suppose the table name is like student. And the query will be like update student set address equal to new address, where student ID equal to the whatever the student roll number. So these kind of query is called the DML statement, or the data manipulation kind of statement. Right? DDL is basically about when you try to build a new table, or you try to say add a new column, drop a new column, delete an entire table, right? Kind of all these are the DDLs. So it's kind of like data definition, right? Because you are defining the structure of your table. So that is called a DDL. And DCL actually it's not that used. It's more of a it's definitely, I'm not denying that it's being used, but it's very rare in comparison to how much frequently you probably use DML and DDL. So DCL is basically about access level control, and some of these kind of like rollback and transaction level concept that you can handle through your DCL. But DCL again is not that important. DML and DDL is the more important ones. So yeah, before I proceed with this, do you guys have any kind of questions so far? so far, whatever you have seen, right? Absolutely, like starting from the beginning, we have covered a good ground in terms of concept, right? But let me check the chat as well if there's anything. So there's nothing in chat. But guys, yeah, do you have any understanding gap or anything, right? Or you want any kind of clarification somewhere? Do you require any such kind of clarification, or is it that I can proceed? Can someone say if you guys are okay to for me to proceed?
Yeah, it's okay.
Feel
You can
free.
proceed.
Yeah. Okay. 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 So then let's continue. So yeah, this is actually it's like it's probably very important concept again when it comes to the schema of the tables, right? Or something called a data model, right? How you organize your data, right? And you build those relationships out of the different tables that you have in order to build that one important business table, which is called the fact table. And the individual normalized tables are called the dimension tables, right? So this is what it basically means. So when you have a lot of, so again, right, before we go to that, I should tell you what dimension table is and what a fact table is, right? So dimension tables are basically, it's like a very like it's like a normalized table again, right? What is normalized? So the best way to probably understand about normalization and what dimension table is that it's the basic level of data that you can have, right? So for example, if you're talking about something like dealer, right, in this case, right, or you something called a date, right? Then you have a date ID for it, and then you have a table for like a year for it. What is the year of the date? What is the month of the date? Or the quarter of the date? And what is the like the day of that date, right? And you may have like product dimension, right? You may have a product ID for that. You may have some attached product name for that. You may have a model name and a model ID and a variant ID. But what happens is that these tables individually don't make sense for the business, right? They are important, but you need to aggregate them, you need to link them, you need to make a relationship out of them so as to really get some kind of idea as to like what the data means, right? And when you combine all of them through and join all of these tables through different parameters, whatever that be as per the business use case, then you get something called a fact table. So fact table is basically it's like a kind of amalgamation of different dimensions, different parameters fields from the different dimension tables into a singular table based on some business relation that is already defined for you. So that is like the fact table. And if a fact table is being derived from multiple dimension tables, and that's basically it, then you can say that it's kind of like a star schema. And you can actually relate to it why it's like a star schema, because you have a center and it's kind of like a related to it. So everything is like arranged in a star format. So this is why it's called a star schema. I think there's one thing I got in chat. So let me check the chat. Okay, so that's fine. So yeah. So again, right. So this is about the star schema, and what is a snowflake schema? So sometimes what you can have is that within the dimension table also there is a possibility of further breaking it into smaller dimension tables, right? Already it may be a dimension table, right? It's not like a little bit of aggregation doesn't make it a fact table as always. But if you have a possibility to expand it, or you have new kind of data that you think what was a previously dimension table can be further broken down into a more simplified form of table, right? Then what happens is that if a fact table is deriving from not only a dimension table but also something called a sub-dimension table, like these example of a variant, or you have like country, you have like location, all these kind of things, then it's called like a snowflake schema, right? So this is the difference, and this is again it's a very important interview question. What is the difference between star schema and snowflake schema? The primary difference is that if the fact table is being sourced only from dimension table. It's the undoubtedly is the star schema, and if the fact table is being sourced from dimension tables, which are again having some sub dimensions tables to it, then it's called the snowflake schema. So that is the idea, and this is the data model. And from practical point of view, right? Again, uh, how does this relate, right? Why is this important? So whenever you build any kind of business report, right, in Power BI, Tableau, whatever it is, right, you need to have a working data model underlying to kind of build that table. So, for example, I'll give you a real-time example, right? So in our industry, right, a lot of customers can have a lot of shipments going from probably China to United States, Europe to Australia. So many different routes shipments are moving on around the world, right? But then at the end of the day, when you are going to send them a bill, right, and they have some special incentives for how much they are performing, or if they are performing above a certain limit, we give them a rebate. All of that calculation, right? You have different dimension table, and then you bring them and aggregate them to a fact table. And based on that fact table, and obviously there are some other criteria as well, but it's a little bit complicated. But let's talk about the simple fundamental. You get all of those dimensions into fact table, and then you build a data model using whatever the required business requirements, and then you deploy it that model into something called analysis service or Power BI. Also, you can build the data model, right, and then you present it to your end user. So the fundamental is you have to kind of imagine, or you have to think about what data model suits best for your use case. So this is like kind of for Azure environment. And again, I'm depending, like I'm emphasizing on Azure because it's like very commonly used for most of the broader businesses, but AWS and GCP also are used. So this is just one example, but the apart from the service names, the flow will still be the same, right? So you have these many different files. Again, you bring them onto the data factory. So data factory is the data ingestion that we talked about last time, right? And data factory is a tool how you can connect to different data sources, how you can orchestrate them, and get them onto some kind of other storage service. So we talked about data lake. So for Azure, it's called a data lake storage, right? And then from the data lake storage, right, there's something called the Databricks. So what is Databricks? Most of you probably know about Jupyter Notebook, right? And in Jupyter Notebook, it's like an individual cell you can perform the operation. Databricks is just like that, just like a Jupyter Notebook. The only difference is that it's entirely on a distributed computing platform, right? It can handle big amounts of data, and it also is based out of it's not just about Python or any other. It can handle Python. It can handle some language called Scala, Spark, and R. So multiple languages can handle. And Databricks is optimized for this querying and all these kind of data processing operations. And then once you are done processing that on Databricks, you can either, as I told you, right, you can send and deploy that model to your analysis service, or you can directly use the connector to your front end visualization tool, for example, Power BI, and kind of report that data and make sense out of the data. So this is the flow about that. And this is how, right, when we talk about big data, what I initially said at the outset, it's not possible for one machine to process or even perform transaction on scale of petabyte data, right? It's and we are talking about petabyte scale, means 1 petabyte is 1,000 terabytes. 1 terabyte is 1,024 gigs. I mean, it's like huge amount of data. I mean, friends, if you ever look into 1 TB of data, it is unbelievable, right? So the architecture now that has happened is, earlier the architecture was like with storage there is compute attached, right? So if you're hiring storage, you also have to hire that much of compute power. But now it's the beauty of the data lake and all of that is that storage and compute is now totally different, right? Storage you pay whatever you are storing, and compute you pay whenever you require that. Compute is maybe provisioned or it can be serverless. So we'll come to that. But yeah, it's a much more better way to decouple storage from compute. And whenever that query is happening, right, so there is a control node. So node means you can think of it's like a machine, right? It's an independent machine with specialized software to deal with all these processes. And whenever you give a query to a big database, right, table, right, for example, maybe 500 GB of data within that, it will distribute that. It will internally it will rearrange that query. It will search for partitions within that data, distribute it in a lot of compute nodes within itself, access the storage parallelly, and then try and pull up and give you a result back. And because it is parallel, and that's the name why it's called massively parallel processing engine, MPP engine, is the reason why you can probably get a better performance in a very, very quick amount of time. If you would have only done it through one node, it would have taken ages to get even a single query running, right? So that's the beauty of cloud. You can scale out at any point in time. You can today you might require 4 engines, compute nodes, right? But tomorrow you may have requirement for suddenly you may require 10 nodes immediately with the click of a button, right? Or it can also be automated. Scale out you can do, and I personally do that. Suppose, for example, when I normally, right, one of the data warehouses, it has, so there are different pricing tiers. So in Azure, you have something called an S0 tier, S1 tier, S2 tier. And as you go up the S later, the price also increases, right? And for example, right, the price, when we're talking about the price, the S2 tier, right, it's cost about 2000 US dollars per month, right? So this is the scale of money that we are talking about, right? And that's why so it's very important that when we talk big data, it's also important to talk how we optimize handling that big data, right? But anyway, so when I use that processing, I scale up from S0 to S2 so that the memory and the compute power is there with the database, and then I process that data, load that data into that data warehouse, and then once that's done, I scale back to S0 tier, which makes it the cost will again be less for any other simpler engines or queries that may be running afterward. So this is like how you can it's a benefit. And as I was telling you, right, you may have provision it upfront, or you may like make it serverless. So basically, serverless is a very trending keyword. But what serverless basically means is that it's kind of like you don't provision it upfront. When you run the query, then the cloud platform determines which are the compute node available free for to run your query. Then it connects to those compute nodes, and then it accesses your storage. But the delimitation of that is that performance is a little lesser, or the latency is a little higher in serverless, because it has to also allocate that kind of resource. Yes. So yeah, so this is about your dedicated pool, and this is about your serverless pool. So we have a dedicated, your performance is guaranteed, but as I said, right, the costs are immense, right? And in serverless, right, it's the cost factor is pretty less, but again, latency will be high. So SCD actually we may skip discussing. But yeah, it's just good to know. Like you can query about it if you ever require it later. So what's like a type 1 SCD and type 2 SCD? But I guess it will be a little beyond scope for discussion. So I'll not go right now. And we'll just discuss about Azure Databricks for a short while of time, and then we'll be opening up for questions and further discussion, right? So Databricks, right, as I showed you, right, Databricks is kind of like unified tool. It's like a unified platform, right? So you have so many different way of getting your data in, whether it's through IoT device, whether it's through being you're fetching it through cloud services, right? Whether you are getting it through data warehouse, any kind of storage, right? You need some processing place where you can aggregate them, you can work on that data, right? And it's not just for data engineers, it's for data scientists, it can be used by analysts, and you can basically schedule tasks and do a lot of stuff within Databricks. So Databricks is kind of like an integrated environment, and it's basically based out of Apache Spark, right? And what is Apache Spark is basically when you handle these kind of big databases, right? It's there's a lot of optimization that you have to do when you run those queries. And before, what we had like before Spark was popular, right? We had something called Hadoop, and we had something called MapReduce. But the problem with MapReduce was the first problem was that it was complicated. Like a MapReduce algorithm, if you have to write it, it's not too difficult, but again, it's not a very convenient process, right? So you have to write all that. And the second thing is that in terms of efficiency, also, it's not kind of very good example of how fast you can process, right, the immense amount of data. What Spark does is it takes a totally revolutionary approach. It has something called a driver, right, and it's something called the executor. So whatever the command, first of all, it it Spark kind of has something called a lazy evaluation. So what lazy evaluation means is that when you give a big query, right away it will not process that query. What it thinks is that how can I optimize this query, right? It will make a plan out of that, how to best how it can shuffle those filters in and out, right, and how best you can optimize, brings it to a very low level, and then it operates on that. So it will try and optimize the query to the maximum possible extent, right? And then Spark performance wise is almost 100 times faster than what MapReduce and Hadoop did, right? So Spark is an absolute revolution today, and every major businesses today involved in data feed, right, is using Spark to process that data. And from Databricks, right, once it's processed, as I said, you can export the data, you can feed it to machine learning models, right? You can go and push it into BI tools that make reports for end users, and you can further process and put it into data warehouse for the storage, right? So all of that is possible. Think Lambda architecture and Kappa architecture probably again it will be a bit too complicated for you, but yeah, let's just take a very simple example and then we will get with this. So basically, again, right, in the data lake, right, how you are going to access the data, you can. There are two models for that. One is through your Lambda architecture, and the other one is I showed you right up front, right? It's called the Kappa architecture. So basically, what Lambda architecture does is that suppose, right, you have some requirement of data, which has to be, latency has to be very less. So it is required immediately, right? Whenever that event is happening, it has to come in and, get it into the like the analytics client or the front end, right? But there may also be some kind of data which is okay to, do it in batch processing, right? So this is the architecture where you have two different paths, right, for the data to flow. One is the cold path through which your batch data can flow, right? You can bring them in periodically, process them periodically, and send it to the analytics client whenever it is done, right? And the other tier is called the speed layer or the hot path. So basically, it's like the streaming data. It comes in. Latency is very less, but again, the accuracy is not high there, and it pushes that into the analytics client. So batch layer or the cold path, if you require absolute precision, absolute perfection in terms of accuracy, you have to go for the cold path. If you require latency to be low, latency is your major factor, then the hot path is your kind of way forward. But then one of the the founder who actually not the founder, like the person who actually proposed this kind of Kappa architecture, right? He said that it's a practical problem that if you are maintaining two different paths, right, there is a problem of maintaining the two different code bases, right? You have a separate code base for your cold path, you have a separate code base for your hot path, and how do you sync them, right? It's very difficult to maintain it, especially you talk about industry, right? It's really there's a ton of scripts that you have. It's very difficult to maintain. So he proposed that instead of going through like two ways, just mirror all of that event to your long-term storage. Anyway, it will sit in the long-term storage, and you pass it through a speed layer only and give it to the analytics client. And if anytime it is required that maybe the accuracy is not or more accuracy required, then you fetch it from the kind of the long-term store, and then you can process and send it back again to the client as and when required. So this is about basically Lambda and Kappa architecture. But again, this is a little more advanced. So it's upon you if you want to really understand more of that. But it's a good concept to know. And for our final section, we will discuss a little bit on data security. So data security is like all the data that you are having, right? It's a very important thing about, right? You may have heard, right? Whenever some kind of hack happens, right? Many credentials are leaked, right? And it's a horrible thing to happen. I mean, from organizational reputation perspective, right? Uh, it's a terrible PR damage, and more importantly, right? You have to pay legal fees and charges, right, in tunes of hundreds of thousands of dollars, right? Because you have not been able to secure the data. So data security is a very critical component, and cloud security engineers are there, and cybersecurity experts are there who deal with that. But at the very basic, right, it's like the end user, right, or the not the end user, the data engineers or whoever works with the data. It's also their responsibility to ensure that the data is being protected, right? So there are some basic ways how we can protect, but one of the most important or like the popular ones options are the NSG and the firewalls. So basically, firewall is basically, I think I have a diagram. Yeah. So firewall means basically, see who can access your database. That's the most basic, way of putting it. So if you have some, if you want, right, that only a specific range of IP address should access your server, you can set like that. Or if you want it to be open to all, you can set like that. There's a ton of customization that you can do. And if at any stage, right, the validation fail, then the connection will be rejected. So there'll be like the connection only will not be established with the database. So there's no question of query. And firewalls are an effective tool actually for kind of ensuring a base level of data security, right? But then that does not only solve the issue, right? Then you have something called IAM, right? IAM means identity and access management, right? So what IAM does is basically there are two things, right? You have to have authentication and you have to have authorization. So what's the difference between authentication and authorization is that let's say, for example, right, that you may walk into some kind of pantaloon store, right, in say Planet One in Bhubaneswar, right? Just giving a very real life example, or a lifestyle store there. You have the authentication to walk into that store. That's fine. But do you have the authorization to go to the counter and check whoever has done the transaction, or whoever has purchased all the detail? That you don't have. So that's the difference, right? Even if you're authenticated, you may not have the authorization to access the resource, right? And authentication is like the base kind of check that you do. So authentication in terms of this example, what I just told you, right? If you are carrying a firearm, right, you are probably not going to get an entrance into the mall itself, right? So that's authentication. It blocks out some of that. But again, once you're authenticated, there are different role types, right? And in Azure, it's called role-based access control (RBAC), and you have authorization tiers that you can access. So that is one more way of ensuring that data does not leak out or goes to the wrong hands. And so one more thing is like encryption. So encryption basically it's like there are a few popular ways. So there is like dynamic data masking. There is something called always encrypted. I think I again have I do have the a diagram for that. So it makes it a little easier for you to understand. And suppose this is the table, right? So you want that the email and the social security number, right, or the phone number, right? These are like it's a sensitive information from business point of view. So apart from the admin, should anyone else who has the read access to the database be able to see that? So if you enable the dynamic data masking, then what it will do is kind of it will introduce some variety, and it will try to mess up that like the view perspective wise, it will try to mess up so that other users can't really understand what that is. But the admin or the user, if he has a right credential to open that certificate and decrypt that particular dynamic data masking scheme, then they can access the data in a like readable format, human readable format. And always encrypted is basically like it's like you create a security certificate in your database, right? You have a master encryption key, and basically like a master encryption key is going to be the key for all of your encryption tasks, and then you create a certificate beyond that, and then you process your encryption, tell that database, right, that you need to process this column and make it encrypted based on this key, right? And you can decrypt also based on that key, right? So it's either way, right? So this is about the always encrypted. And as I said, right, last thing is about the data factory. Again, this is kind of similar to the data flow that you saw firsthand. So I don't think this should be a very important one. We have already seen this kind of flow earlier. So Power BI, yes. So Power BI is basically it's like the front end tool, right? I told and I talked about. So this front end tool is basically like how you report, right? All of that data is fine, but how do you want to present it to the user? You can present it to some service like Power BI. There's a lot of other tools. I personally love Tableau, but it depends on the organization of which organization uses which software, right? Right. So this is how you, and it's very interactive and it's very easy to for the end user to understand the data if you present it in a report or a dashboard format for them. So data factory component is like in Azure Data Factory, like which is the ingestion tool, right? You have something called a linked service. So, for example, if you are picking data from our database, right, so SQL Server, then the link service must be connected to the SQL Server first. Then what you have is something called a data set, right? Within that link service, or wherever you want to, suppose you kind of want to dump that final process data, right? You want to create some kind of table or a file where you want to dump the data. So it is like the data set, right? The activity is like what operation you are doing on that. So, for example, you are doing a copy data, right? You want to move a part of the data from your SQL Server to your Azure Data Lake storage. That's an activity. And then finally, you may have like multiple activity, right? You may want to first ingest the data, push it to data lake. Then you might want to execute a Databricks notebook, and then you might want to again extract that notebook and do something else, right? And feed the data into some ML model or something. Pipeline basically it is a group of all these different activity, and you can schedule that pipeline. So this is the overall kind of architecture of Azure Data Factory. So this is just a visual way of understanding. So you have like link service, you can link it to data lake store, you can link it to Databricks as well. You want to target data set from where this data should finally land up. So that's a target data set. You have so many different bytes streaming in, and whatever it is, right? You think about this as the data, right? And then you have the activities, right? So activities is basically it's like all the processing, right? And whatever intermediate steps that you are doing, right? And when you group it together, it's called the pipeline, right? So you put it in a pipeline, right? You bring all that process, transform all that data, and finally you can keep a schedule, which is called the trigger in Data Factory. So, for example, every 12 hours it will repeat, right? This pipeline will repeat, and the entire process will happen again. And so every time a trigger happens, it will repeat kind of that entire operation, right? And now finally that data will, one by one, it will come and fall in that data set. And these are some other like parameters, not very important as of now, given that you have the fundamental understanding. So yeah, that is about like the presentation part of it, like what I had, right? And let me quickly check if any doubt. Okay. So yeah, I mean that was it from the presentation point of view, guys. But I hope you guys benefited, right? There's no point of me speaking for 1.5 hours if you guys do not benefit out of it. I just want to hear from you if you guys have any doubts, right? And about some of the feedback that you may have, right? Or what you want to know, right? And anything else, right? So you can also feed in fill that feedback form link which is given, or you can also, it will be better if you can interact with me, right? Given that we have some amount of time, right? I see a lot of you, and I wish that some of you at least get some inspiration and join us in a pursuit of making data engineering kind of more inclusive in terms of the people who represent from our generation, right? So tell me, guys, if you have any doubt.
I was
So is
asking
there
yeah. So
yeah,
excuse me. Yeah. So I was asking if we would be taught how to use the Azure Data Factory and all in later stages.
Yeah, so that is something that we can do, Vaibhav. For now, actually, I have organizational access, but I unfortunately cannot share that right in a stream because that is sensitive. But yeah, I'll think about it. I think it's a good option. The only thing is
Yes,
that,
Sampath.
yeah, just for demo, right? We can, yeah, definitely we can use. And in the meanwhile, also we will think about it and we'll probably schedule a second session, right? But I mean, from my experience, it's not a lot of people actually know about big data engineering, right? All of these concepts that I told you today, right? They are mainly kept it in a very theoretical format. Most people they don't know about how the industry works in terms of big data. And if you really go out and search for big data or data engineering jobs, there's a ton of money that's being made by a lot of engineering, like data engineer practitioners. It's a great opportunity for you because unless there are data engineers, right, you don't have any use of data analysts and data scientists, right? So it's kind of like a foundational step. So you can definitely explore, right, more. And I hope you have enjoyed the session. Also, I hope it was not boring for you. So anyone else with any kind of feedback? So Vaibhav made a great example, right? If we can have one demo session, we will definitely look at that. But if you have any feedback about how my teaching style was, or whether you found it a little bit advanced, a little bit fast, anything, right? You can let me know.
I actually have a question from the PPT itself, like where you
Yeah, yeah,
discussed
sure.
about the SQL pool table, right? Where it was written
Yes,
the dedicated and the serverless.
yes,
Yeah,
yes,
that
yes.
difference I actually didn't get.
Right. So, for example, right, the serverless, any kind of serverless feature that you have in cloud, it means that it will only provision the resource at runtime. Right, it's not allocated to you. So when the resource is allocated to you, right? So for example, you have 5 compute nodes allocated to you at every point of time, irrespective of whether you need or not, it is allocated to you. So the moment you run that query, definitely those 5 nodes are being engaged and immediately the results and operations are being started. Right. So performance will obviously be much better. But if you have a serverless SQL data warehouse, right, what happens is none of the compute engines are provisioned for you. So when you process that query, when you give that query to the engine, then it looks to allocate, right? First, it will search which are the compute node or which compute engine are free for this operation. Then it will, assign them to your process. Then it will link up with the, target data store from where you are trying to operate. And then the process of that MTP engine will begin. So definitely it will take a lot more time, but the only benefit of SQL or any kind of serverless operation is that it's very cheap. Just to give an example, in Azure Data, right, service, right, if you provision a SQL database upfront, right, cost can go up to 3-5,000 rupees a month, right? And I'm telling about the very basic tier, right? But if you're talking about SQL serverless, right, it's about hardly 300-400 rupees, right? So that
Hmm.
the price difference should be a kind of clear pointer.
Understood. Thank
Hope
you.
that's clear, Shomik.
Yeah. It's right. Thank you.
Yeah. So yeah, guys. So thanks again. This was pretty much it, and I'll share you the LinkedIn, my LinkedIn address. Okay, you guys can kind of send me a connection request, right? And we can connect and we can discuss further, right? So this is my LinkedIn, right? You can also connect here, and definitely through elabs also you can follow elabs, right? And participant certificate, Sukritan, you will get from our team members. So there are team members who are involved, so they will process and you will get it very soon. So if you fill up the attendance requirement or any of the feedback, if you can give, it will be great. But if you fill up the attendance, definitely will be eligible for that certificate. But yeah, guys, like more important, more than just a certificate, right? It's more the like important, like what you take away from it, right? So it's not just about certificate. And honestly, like when you go to your fourth year, certificates won't really matter as far as how many projects you have done and all that. But yeah, the most important thing is that you understand and because all these kind of webinars are very people charge a lot of money, right? 1,000, 5,000 rupees a charge for a session of webinars on big data engineering, and just for the fundamentals, right? It doesn't make sense. I just felt that there's no one who is doing it for free. So at least we are offering a platform, and personally I love talking to all of you, right, and teaching you. Is I've been doing that from my second year itself. I used to teach Java earlier, and now I've been expanding in a lot more domains. But hope all you guys enjoyed, and that's it, guys. So if you want to log off, you can log off, and if you want to discuss anything else, you can stay back and ask me. So take care, guys. Bye, and thanks for attending today's session.
One last question I had, that is there any
Yeah.
book that you followed in your time to learn about this data engineering in depth?
So,
Like,
so Shomik, SQL and all and RDBMS, I have learned like from the my academic books and like YouTube. But I'll recommend you, if you are interested, right? You can get a book called a Spark: The Definitive Guide, right? You can note this book name down, and I have this book with me. And you can probably also get a PDF copy. And if you connect with me on LinkedIn, I can share you that PDF copy. It's a great book. I think everything at fundamental, right, from the architecture, how you can optimize performance, how Spark works, and everything. It's a beautiful insight into data engineering in itself, right?
sir,
So
I've
you can
already
follow
sent
that.
you the request. So if you can, I'll if you
No,
accept.
sure. I will connect. So I have not actually opened up yet, and
Yes. Okay.
I'll check. Yeah, I'll check and I'll do that. No
Okay.
worries.
Thank you.
Yeah, don't call me sir or anything. You can call me Dipankan. It's fine.
No, I'll call you Bhaiya. That's good.
That's up to you, man. Chalo. Okay, guys, if you don't have anything else, I'll also log off. So, yeah, ta-da, bye.